Hi, welcome back. In this lecture, I'm going to introduce this. That is a tool that allows us to see what is the low-level translated bytecode from the high-level Python code with which we write our code. By the end of this lecture, you will be able to use this module, where this stands for disassembler, to inspect the Python bytecode of selected high-level function of our code. Also, we will be able to analyze the results of this output. Let's spend a few words about the Python bytecode, what it is about. So Python is often described as an interpreted language. This means that our source code is translated into native CPU instruction as the program runs. So this translation happens at runtime. This is only partially correct. So it is interpreted, but it is interpreting the so-called bytecode. So Python, like many interpreting languages, such as Java, actually compiles source code to a set of instructions for a virtual machine. This intermediate format is called the bytecode, and we're going to look at how this bytecode looks like. We are going to use this tool to go more into detail this bytecode. It turns out that this is going to allow us to understand how the high-level Python code is translated into low-level and how a different version, different possibility of implementation translate to different bytecode. So the Python interpreter is actually an implementation of the virtual machine that is taking this compiled bytecode and is running the binary, the executable that is in binary. During this module, we have reviewed various ways to measure the cost of the Python code, from the CPU to the usage of memory. We haven't yet looked at the underlying bytecode that is used by the interpreter at the runtime. Understanding what's going on at a lower level, under the hood, help us to understand and have a mental model of what's going on in this low function, and it will help when it comes to compile our code. So we are looking at now how to obtain the Python bytecode, and for doing that we're going to use this module. This that stands for disassembler module lets us to inspect the underlying bytecode that we run inside the stack-based CPython virtual machine. Having an understanding of what's going on in the virtual machine that runs our higher-level Python will help us to understand why some style of codings are faster than others. It turns out that in many occasions there are different ways to implement a certain thing, different solution. So one way to understand which one is better, other than actually run it and time it, is also to look at the bytecode. Some bytecode is better than the other one when it comes to performance. It will also help us when we're going to come later on in this course to use a tool like Cython, which steps outside of the Python and generates C code that we can call from a Python code. This module is built in Python, so we don't need to do any extra installation. We can pass it code or a module, and we'll print out a disassembly. Let's look more into detail and practice on how to use this module. So the way to disassembly a function, for instance, we have our function in juliaset.py, that is our code to generate the Julia set. We start our Python, so we do command line Python, and we do import Julia set, because Julia set is the code that you want to disassemble. We imported this, that is the module, to disassembly, and then what we do, we call this and we provide the name of the code dot the name of the method that we want to disassemble. If you run this, we're going to get the output that is on this right side of my slides. Let's look more into detail how this output is organized. We know that the first column is actually the lines of our code. So we can go back to our code, original code, and look at line 63 and how the line 63 is actually translated to the actual bytecode. So the first column is the line code in our source code. The second column is this double arrow here. This is nothing else that the destination for jump points elsewhere in the code. So in this case, for instance, we have a jump for the for iteration, and also here we have a jump iteration, a jump point. The third column, that is this one. Here is the operation address. The fourth column, probably the most important one, is actually the operation name. So we can understand which operation are called within the line. Then we have in the fifth column contains the parameters for the operation. And the sixth column, the last one, just contains annotation to help line up the bytecode with the original Python parameters. Let's look at an example for the first column. The first line that has been disassembled in 8 Python bytecode. So the bytecode starts on Python on line 63 by putting the constants value of 0 into the stack. So we have the value of 0, and then we do a loading operation. And then it builds a single element list. So we are going to be here, a single element. Next is search the namespace to find the len function, put it on the stack, searches for the namespace again to find ZS, and then puts back on the stacks. So these are the function that I've just described here. It calls the len function from the stack, which consumes the Z reference in the stack. So still we are here. Then, as a next step, we apply a binary multiply here to the last two arguments, the length of ZS and the single element list, and we store the results into the output. This is just a brief analysis, understanding what this simple bytecode. So we can apply the very simple analysis for other lines of our source code. This is my last slides of this lecture. I briefly introduce a tool to disassemble a bytecode that allow us to see how from the high-level Python code we go to the bytecode that is used by our Python virtual machine. To summarize the points of this lecture, this module allows us to inspect the Python bytecode. Second, investigating bytecode might help us in understanding how high-level Python is translated to low-level bytecode and compare different approaches. So if you know that there are different solutions for solving one problem, we can time it, different solutions, and choose the best, but also we can understand one solution is faster than another one by analyzing the bytecode. This is the last slides of this lecture. Talk to you soon.